have us, bless you, just review how to solve just a basic system that has two lines in it. So I've just got two linear equations here. The highest power of x is just one, just a plain x. I don't have anything squared, right? So I've got x equals 4y minus 25 and negative 2x minus 2y equals negative 10. Can anybody remember how they might go about solving that? Like, what would you do? Eli, what do you think? Yes, I would just do a little substitution here, right? You got x by itself, so super easy. We'll just plug that in for x in the other equation. Now, when I do that, everywhere I see an x, we're just going to put the 4y minus 25. Since it's got two terms, I would always recommend to you just put it in parentheses if it has something in front of it for sure, so that way you don't forget to distribute whatever that number is. It's going to be negative 2 in this case. I got to distribute that to that entire expression that was getting put in place of x. So negative 8y, negative times a negative makes that positive 50, and then I have a negative 2y. I would just combine my like terms there on that left side. So I've got, what, negative 8 and negative 2 would make me negative 10y plus 50 is equal to negative 10. And then we're just solving this equation. I know you guys can do this, so we're going to subtract the 50. Negative 10y would equal negative 60. What would y equal? 6, right? Okay, now, is that my answer? What do I have to do to get my answer? Like, what am I looking for? Yes, you got to plug y in. I love how she said that. You got to plug y in to find x. When you guys are thinking about this, a solution to a system, when we've got two lines, it's the point that they have in common. So basically, I have half my answer here because I have the y coordinate. I need the x coordinate of the point. So you're going to plug that back in. Is either one of these equations easier than the other to plug that into? Just trying to save you some time. Yep. Okay, if it was me, I'd plug it in right up at the top, right? Because that's already got x by itself. Just do 4 times 6 minus 25. Maybe you would not even write that down. Maybe you would just do that in your head. But x should end up being negative 1. But I need the x coordinate and the y coordinate to get my whole answer there. So it should be a point that they have in common. Is anybody having a question? Okay, now, like I said, we have done this with a graphing calculator or Desmos where we had intersection of a line and a parabola. We're going to do it algebraically today. So I'm not going to put, if you wanted to put this on your calculator or put this in Desmos to check your answer, completely fine. But I have to show that you guys know how to do this using algebra. So here's the deal. I have a quadratic. That just means the highest power is x is going to be squared. So negative x squared plus 6x minus 7. That's your quadratic. The other equation in that system is just a line. Just y equals mx plus b negative 2x plus 5. All I would do here, extremely similar. I'm just going to use some substitution there. Okay, so all you're going to do, they're both equal to y, so they're both equal to each other. So we're just going to literally substitute in that entire quadratic. So I'm going to write x squared plus 6x, negative x squared plus 6x minus 7 equals negative 2x plus 5. Okay, now, maybe tiny little note here, and it might be more work, it just depends on the question, but you want to set this equal to 0 for sure. And the other thing I would recommend, you want your quadratic term, I'm going to write ax squared. In this case, it's just negative 1x squared. You want that term to be positive. If it's not, move it to the other side of the equation. So for this example, what I'm going to do, I'm going to take that whole quadratic and move it to the other side of the equation to set it equal to 0. That will allow me to get an a value that's positive. So I'm going to go through here. I'm going to add x squared, subtract 6x, add 7. So I'm just doing the opposite of each operation that I had there to move that to the other side. So we're going to add x squared, nothing to combine that with. Subtract 6x, I'm going to combine that with the negative 2x. And I'm going to add 7. I'm going to combine that with the 5. So we're going to get x squared, nothing to combine that with. Negative 2x, negative 6x, we got negative 8x. And my plain numbers, I got a 5 and a 7. So we're going to add up to get 12. And once I'm there, then I'm going to see if I can solve this by factoring. So, can you guys, and this would just, it just starts off with a plain x squared. So I'm just going to start both of my factors off with an x and an x. We won't do anything, there won't be anything to reduce here like the Berry method because I don't have a number in front of the x squared. Can you guys think of two numbers that you'd multiply together to get 12? The same two numbers would add and get you -8. Perfect. -6, -2. What are my actual answers to that equation? What do you think? 2 and 6. Okay. Now, are those my answers to the question? Okay, this always throws people off. You have two answers here. What these are both x values, but for two different points. So if we actually graph this, the parabola and the line would run into each other in two different points. So you actually, when you plug back in, you have to plug both of those numbers back in. We're going to have two different answers to this question. So one of them will have an x value of 6. The other one will have an x value of 2. Now, it is completely up to you, but I would recommend, if you have a line in the system, I would plug it back into the line because there's less things to type, basically. So I'm going to plug in 6 for x. So in that equation for the line, I just have -2x plus 5. So I'm just going to do -2 times 6 plus 5. Don't judge me for typing that into my calculator, which I just totally did. All right, so -7 would be the corresponding y-coordinate. And -2 times 2 plus 5, oh, not 55. Corresponding y-coordinate there would be 1. If you do want to plug it into the quadratic, it should be the same number. So I'll just do the first one as an example. If I do negative and then I have x squared, let's just do the 6 as an example. 6 squared plus 6 times 6 and then -7, not a decimal point, okay. That still gives me the -7, so it's still the same point. So you could plug it into either one, but I would tell you it's probably faster to plug it into the line because there's less terms that you'd have to plug in. Is anybody having a question? Okay, now, the one beneath this, I don't have y by itself in the second equation, right? I just have the top y equals -2x squared plus 8x plus 4. That's good to go. What I would do here, just take this second equation real quick. Let me get y by itself, and then we can just use some substitution. All I would have to do that, I'm going to add y to the other side. And just in the same step, because I'm being lazy, in the same step, I'm going to move the 12 to the other side. So I'm just going to try to get y by itself. So add y to the left side, and I'm going to move the positive 12 by subtracting it, get it to the right side. So that second equation is really y equals 2x minus 12. Just manipulating it to make it easier to do. Once you got that, then you're good to go. I'm just going to set these two, they're both equal to y using substitution. So I'm going to set them equal to each other. Let me grab a pencil. All right, now, maybe. So I've got -2x squared plus 8x minus 4. It doesn't matter which one goes on which side. And you've got 2x minus 12. Now, what I would tell you, remember, we want to set this equal to 0. And I want my squared term to be positive. So completely up to you how you want to do this. But if it was me, I'm actually going to add this entire quadratic or subtract, depending on what the operation is, the whole thing to the other side to cancel it out. That'll give me a squared term that's positive. So I'm going to add 2x squared, nothing to combine that with. I'm going to subtract the 8x. We'll combine that with the 2x. And I'm going to add the 4. So we'll combine that with the -12. So this whole side would just become 0. And then I'd have 2x squared, nothing to combine that with. 2x minus 8x is going to be minus 6x. And then -12 plus 4 would be -8. All right, now, what do you all notice about all the terms in this lovely divide by 2? Okay, so let's just get rid of it. Then we're just working with smaller numbers. Makes it so much easier. Get rid of it, everybody, including the 0. 0 divided by a number is 0. So we get x squared minus 3x minus 4. Okay, let's see if we can factor this. So can you think of two numbers when you multiply them? Both factors would just start with x, right? Because I just have a plain x squared. We got rid of the 2, so we don't have to worry about the Berry method. We had a greatest common factor, so we got rid of that. Can you think of two numbers that you multiply together, they give you -4, add, you get -3? Yes, okay. One's a -4, one's a +1. What are my actual answers to that equation? Yes, so 4, -1. Okay, remember, because people always forget, what that means, these are both x values. It means if I graphed this, the parabola and the line would touch each other in 2 different points. So when you write these guys down, remember, you're going to plug both of those back in. And it's completely up to you, but if you're working with a system that has a quadratic and a line, I would plug the x value into the line. It's just less work, and I'm lazy and I'm all about less work. Okay, so I'm going to take it and plug it in right where we manipulated this a little bit. So we got y by itself, so I'm going to do 2 times 4 and then -12. So the corresponding y value there is going to be -4, and then I'm going to do 2 times -1 minus 12. And you don't have to use a calculator for this, I'm just doing it. Corresponding y value there would be -14. So if we were to look at this on the graph, those are the 2 points that that line and that parabola would have in common. Is anybody having a question? Okay. Now this next one, I'm not going to lie to you, this next one's a little bit harder. So I've already got the quadratic and the line just both set equal to y. So let's just set these equal to each other. I'm just going to, substitution, both equal to y, so they both have to be equal to each other. So I'm going to write 6x plus 14x plus 4, and we want to see where that runs into the line that's got the 3x plus 1. Now for this one, my squared term's already positive, so I want to keep that positive. So what I would actually do here, let's move the 2 pieces for the line, the 3x and the 1, to the other side. So we're going to subtract 3x and subtract 1 to help us set that equal to 0. All right, now I'm going to get 6x squared plus 11x and then plus 3. Now I don't have a greatest common factor there. So if you like the lovely Berry method, that's what I'm going to use here. Just at the beginning of both of your factors, don't forget, whatever that first term is, I got 6x squared here, right? Just drop the squared and put that 6x at the beginning of both of the factors. And I'm going to write this out here real quick to the side. So I'm multiplying a times c, add to b. In this question, the a value is the 6. So first times last, this would just be 6 times 3, so that'd be 18. And then I want to add up to that b value, which is 11. Can you guys think of two numbers we could multiply to get 18 and add to get 11? What do you think? 9 and 2. All right, both of them are positive. Doesn't matter which one comes first, which one comes second. Now, in this case, remember, that's not really the factored form if the two terms have anything in common. In this case, both of these are the wrong factor. All right, if you look at, I wrote 6x plus 9 first. Those two are both divisible by 3, and I wrote the 6x plus 2 second. Both of those terms are divisible by 2. All right, so the real factors, this one would be 2x plus 3. The real factor here would be 3x plus 1. Can anybody raise your hand, tell me what are the answers or the zeros for this one? A little trickier with those parentheses having a number in front of the x. Dee Dee, what do you think? Perfect, perfect. Okay, now I know this is a little annoying, right? But you're just going to grab your calculator. I'm not going to have you do any of this by hand, but we're going to plug in those two fractions. Again, I would totally just recommend let's plug them in to the line, but these are both just your x values. So you need the corresponding y value for each. All right, so one of mine has an x coordinate -3/2. The other one is -1/3. So I'm just grabbing my calculator. So 3, and I'm just going to use the little parenthesis key. I'm going to do negative button 3/2. So just do a -3 divided by 2. and then I'm going to add 1 to that. Now, that ends up being negative 3.5. If you want to write negative 3.5, I am completely fine with that. If you prefer to do it as a fraction, just hit that math and then hit enter twice. This is the same thing as negative 7 over 2 if you'd rather write it as a fraction. I honestly don't care, whichever way is easier for you. For the other point, we got to plug in negative 1/3. So I'm going to do 3 times negative 1/3, and then I'm going to add 1 to that. That actually just ends up being 0. So that's a nice y value for that question. Is anybody having a question? Okay, now, my last 2 examples. These guys are actually 2 different quadratic equations. So 2 different parabolas. All the other systems we've been looking at, other than the very first one, which was 2 lines, were a parabola and a line. So this is 2 parabolas. All right, so both equal to y. I'm just going to use substitution, so I'm going to set them equal to each other. So I would have negative x minus 1 squared plus 2. So that's sort of what we were used to with our vertex form when we were doing the graphing. The other one is x squared plus 4x minus 3. So that's standard form, what we were used to with when we were doing our graphing unit. All right, what would I do to solve this? Yeah. Here's what I'm going to do. Let me just pull this to the side. If they give you something in that vertex form where you've got parentheses with the square, I'm just going to come over to the side. Let me just put that in standard form real quick. So this will be a little bit of a review that we've done in our earlier units here. Okay, just keep the negative out in front. Remember, if you have x minus 1 squared, it just means you're multiplying it by itself. So you're just going to write it twice. I've got x minus 1 squared, so that turns into x minus 1 times x minus 1. Just write it twice. And then I have this plus 2 sort of on the edge. What I would tell you to do, just focus, leave that little negative out in front. That's like a little negative 1. Just foil that or box that, however you like to multiply that out first. We're going to end up with x squared. It would be minus 1x minus another 1x. And then negative 1 times negative 1 is positive 1. And I got this plus 2 on the end. I got a little negative out in front. If I combine my like terms, it'd be x squared minus 2x plus 1. I had that plus 2 on the outside, but I want to make sure I don't distribute the negative to that 2 that was added to the end, because that's not part of it. So only distribute the little negative 1 to what you foiled out, what was in the parentheses there. It's just going to change each of the signs. This would be negative x squared plus 2x minus 1. And then we had the plus 2 on the end. So then I can actually combine the negative 1 and the 2. All right, sorry, I know that's a lot of work, and if you guys can do that in fewer steps than I did, you feel free. But I'm going to go back, and now I'm going to just put the standard form up there. All right, so the standard form of that, negative x squared plus 2x plus 1, once we multiplied that out, and then I got x squared plus 4x minus 3. That was just the other quadratic there. Now, set this equal to 0, and I want to keep my squared term positive. So to accomplish that, I'm going to add this x squared, subtract this 2x, and subtract this 1. So I'm going to have x squared minus 2x minus 1. All on that left side of what I was writing down, it's going to be 0. And then I've got 2x squared plus 2x minus 4. Okay, what could I do next? What do you think? Yeah, heck yeah. We got a greatest common factor. Let's just get rid of it. Everybody there is divisible by 2, so get rid of it. All right, I've got x squared plus just 1x, and then minus 2. Can you guys, both of these factors would just start with a plain x, because I've got an x squared. So can you guys think of 2 numbers multiplied together would give you negative 2? The same 2 numbers added together would give you positive 1. What do you think? 2 and negative 1. So one of these is a plus 2, one of these is a -1. That's your factored form. All right, I know this is a lot of algebra here. My two x values then, so these two are going to intersect in two spots, two different points, -2 and +1, and I'm getting super close to the little line I wrote down. Now, it's totally up to you. In this particular case, I wouldn't necessarily say one equation is either easier than the other to plug it back into. I might just use the first one, but we're going to have to plug these into a quadratic to get our y value because one of our, or both of our lovely equations were quadratic. All right, so I've got -2 and +1 as my x values. I would just grab your calculator. I'll just do the first one. So I'm going to do -2 minus 1. We're going to square that and then add 2. Oh, shoot, I just added 3. Add 2. So -7 is going to go with the x value of -2. And then I'm just using the first equation. The other x value had 1. Oh, why did I type that? 1 minus 1 would be 0, and then plus 2. So this will be 2. So my two answers, -2,7 is one of the points, and 1, 2. And you can plug it into either equation to get those y values. All right, I have one left. Now this last one's a little bit weird. So what I'm going to do, let me just do this to the side here real quick. I'm just going to multiply that first one out and put it in standard form real quick. So we're going to have x plus 3 times x plus 3. And then -4 on the edge here. All right. Can anybody cheat a little bit? Tell me what would my linear term be? What would the x term be there if you FOILed that out? Can you figure it out without writing it out? What do you think? Not yet?
X squared plus 3x or 6x.
There you go.
6x.
Perfect. All right, -4. Let's get rid of the negative. So this would be -x squared minus 6x minus 9, then -4. All combined, -x squared minus 6x minus 13. Okay, now, this is going to look really weird, but I promise you can solve this. All right, so the standard form for that first equation in that system, when we multiplied it out, -x squared minus 6x minus 13 equals, the other equation is x squared minus 6x plus 1. Okay, keep your squared term positive, so here's what I'm going to do. I'm going to add this x squared, I'm going to add this 6x, and I'm going to add this 13. Now, what you guys are going to notice, and this is a little bit weird, gone, right? This is 2x squared. That linear term ends up canceling out because it was the same for both of them. So this is going to be my equation. I have 2x squared, and then just 1 and 13 would be 14. Okay, so I just have an x squared here. Anybody know how to solve that? We haven't done any problems like this yet, so I don't know. Could you get x by itself there? Like, what would you do? What do you want to do? For sure. This isn't like the other questions where we have an x squared and an x and we can't combine them. I just have an x squared, so you can actually just get it by itself. So we'd have -14 equals 2x squared. Then what do you want to do? Yep. Okay, how do I get rid of the x squared? You just square root. Square root and squared cancel each other out. Now, here's my question to you. What's the square root of -7? This is an imaginary number. Okay, yes. Now, in terms of this right now, we're just going to write no real solution. If you were to put these two on a graph, would not touch each other. If you actually tried to do this on your calculator, if you actually went in and you did like the square root of -7, it'll give you an error message is what it'll do. It'll be like, oh, can't do this. It does have an imaginary answer. We're going to do that later in this unit, but for our purposes today, If you cannot take the square root of that, if it's a negative number, can't take square root of a negative and get a real value, just go ahead and write no real solution. So those two parabolas, if we were to look on a graph, they just don't run into each other at all. If you guys wanted to, here, tell me what, I'm just gonna pull up my Desmos real quick and I'll just show you. I can just type this in and look on the computer if I want to. So we had y equals negative x minus 3 squared and then minus 4, right? That was the first one. And the second one was y equals x squared minus 6x plus 1. Oh, I just screwed something up, didn't I? Oh, this is plus 3. There we go. But you guys can see if I move this a little bit, those two parabolas just don't ever run into each other, so there's no solution. If you want to use Desmos or your graphing calculator to check any of the questions you're working on today, you feel free to do that if you want to. And calculators are over here if you need one. If you're borrowing one, borrow one of the gray and yellow ones because the ones that